So quantum and AI are two topics that are going to become more and more entangled, and there is pun intended there. Quantum computers, as they become more and more powerful in the coming years, are going to supercharge AI. And we need to have conversations, open conversations about what AI is, the safety protocols around controlling AI, and the potential negative outcomes if AI is not controlled. And I've pulled up some videos here. We have a few from Bloomberg, and we have a video from a Nobel Prize winning machine learning scientist who is raising some caution about AI and where it's going. So we know that this is an incredibly hot topic in the science world, in the computer world, in general. There's this race to who can build the best AI the fastest. And we're not stopping really to think,
Yeah, but your scientists were so preoccupied with whether or not they didn't stop to think if they should.
what could happen if things go wrong? And I spent a lot of time thinking about that. And I think it's responsible that we all spend time thinking about that. So we're going to go into that in this video. There's a series of reacts, and hopefully you'll find this content thought-provoking and informational. Let's jump right in. All right, so I got the headphones on, and so I can listen along with you. And we're gonna take a look first at the race to harness quantum computing's mind-bending power. I've selected a couple clips from here. I'm gonna do some reacts. Let's jump in.
I think when quantum computing comes up in conversation, people are excited about it, but they're excited about the amount of power it gives you, about how quickly you can do computations. Because, okay, sure, all of that stuff might be true, but we should be thinking of this as though someone has just invented the telescope. And all of a sudden, we can see and understand things at a scale that we just did not have access to before.
That's the ambition, at least. Quantum computers cannot yet perform useful calculations better than a supercomputer, because in practice, getting even a handful of qubits to give you a reliable answer is phenomenally difficult.
And it's supposed to be difficult. It's supposed to be hard. I don't even think we were ever meant to do this. So that's the crazy part of all of this.
Now you got it.
And then you go straight.
Oh my God. Whoa.
This is IBM's lab where they test out new hardware, a place where we can see the guts of the machine.
Oh, that is extraordinary. This is what System 2 looks like inside?
Yeah.
What are we looking at then?
I think a lot of people have a slight misconception and they see, this whole gold shiny thing and they think this is a quantum computer. That's actually not true. This is the quantum computer. So this tiny little thing, right? This is the Heron chip. This is the 133 qubits that I am holding in the palm of my hand.
How much is that worth?
A lot.
So that is a good opener here, just to set some context for what we're going to talk about, because we're going to be talking about these quantum computers and how they continue to get better and better and better, and how AI is continuing to get better and better and better. So what happens when quantum is training AI and AI is training quantum? Well, it's already happening.
Research and development than ever before.
Whoever is the first to realize the potential of quantum computers will wield incredible power. But it's a double-edged sword, because a world with quantum computers could be a world without secrets.
Pretty much all internet communication is based on scrambling it using a secret code, otherwise known as encryption. And a lot of it uses a very clever mathematical trick involving prime numbers. What you do is you take two prime numbers, let's say
17, and 31. And then you multiply them together to give you a code. In this case, 527. Now that bit is very straightforward, very easy for computers to do that, multiply numbers together. What is much harder is if you only have the long number, working out what those two secret primes were. The only way that you can do this with classical computers is by checking through all the prime numbers just to see if they work, one after the other after the other. A common type of encryption, RSA, uses prime numbers that are hundreds of digits long. To crack those codes, it would take a conventional computer trillions of years. That's really the obstacle of encryption. It's not that it's impossible, it just takes a really, really long time. This is where quantum computing comes in, because quantum computers using superposition can simultaneously run numerous calculations at the same time and can take something like this down to being crackable within just a few.
So that sets a little bit of the stage for, okay, so we have a more powerful machine and we have this powerful AI, right? We know that even ChatGPT in the last 2 to 3 years has become exponentially more powerful from its earliest iterations. So let's kind of watch the end of this video, and then I've got a couple more clips that I'm going to react to, and we're going to pull this all together.
Tell me about the information that you're sending using this method at the moment then.
So in the case of HSBC, it's financial data, but we've done other trials with hospitals, for instance, where they've been sending medical scan data, or with governments where they've been sending some government data.
Do you feel this sense of urgency from companies then, even though we're not quite there yet with quantum computers?
Yes, they absolutely are. There's an increasing realization that the quantum computer is coming.
How far away do you reckon it is?
Well, no, that's a very difficult question to answer. If I was a betting man, maybe I would say 5 to 7 years.
Okay. And for those of you who haven't seen the video, definitely go check it out on Bloomberg Originals, The Race to Harness Quantum Computing's Mind-Bending Power. This segment particularly was about how banks and other organizations are starting to secure financial data with quantum safe encryption. And he's predicting that quantum computers will be here in 5 to 7 years. My personal opinion is it's going to be even faster than that because there's so much money being poured into this and so much competition in this space and so much tech to propel things forward. I previously predicted on my channel that we'll have a decently powerful quantum computer within 2 to 4 years. Don't quote me on that. I could be wrong. I'd trust this guy over myself, full disclosure. But that's just my opinion. All right, let's take a look at what does the AI boom really mean for humanity.
AI researchers seek to build a machine that can do all of this better than any human. Dream big, put the spoon in the pot. Start small. Worked out which one the spoon is.
There we go.
Hey, it's in. That's cool. I'm impressed. Good robot. While chatbots are impressive, language models on their own might not be enough to reach super intelligence. Sergey Levin and his PhD student Kevin Black say it might only be done once AI has been given a body, a way to physically interact with the world. Put the green spoon on the towel. Here we go. This robot might not look cutting edge, but unlike the slick robots on factory floors which follow precise choreography, this one learns every action for itself. That's basically perfect.
Yeah.
So what difference does having a body actually make then to the way that we learn?
You ask a language model to describe what happens when you drop an object, it'll say, okay, the object falls. But understanding what it really means for that object to fall, the effect it has on the state of the world, that's something that becomes much more immediate when you actually experience it.
ChatGPT doesn't understand gravity, but your robot does.
Well, ChatGPT can guess what gravity is based on people's descriptions of it, but it's a reflection of a reflection. Whereas if you actually experience it, then you get it right from the source.
Do you think that AI needs to have a body?
Well, I don't know if it needs to have a body, but I know that if you have a body, you can have intelligence, because that's the one proof of existence that we have.
Put the mushroom in the silk.
So a super interesting concept to think about, right? That ChatGPT can't really know what gravity is, but it can conceptualize the rules through the knowledge that it's gained from us. And once we give artificial intelligence a medium to interact with the world, to interact with the world like you and I do, as I'm speaking to the camera at this moment, I'm interacting with the world. Well, we can train an AI to do tasks both simple and complex. And as AI improves, we see, like, for example, with NVIDIA's CUDA models and NVIDIA's advanced AI chips, that they're able to use what's called synthetic data and train robots in millions of simulated environments. So the steering wheel is red or orange, it doesn't matter, because they know that a steering wheel can be a different color. Picking up a spherical object or a cube, they've learned in the synthetic data. So you can see how the training, the synthetic data in robotics and the advances of AI can start to compound and create some potentially different situations for us in the future. Let's keep watching this. What does the AI boom really mean for humanity?
Are there other concerns just with artificial intelligence that's actually really good at doing stuff?
Yeah, you might wonder if AI systems are so capable, then companies will use them to do pretty much everything they pay human beings to do. And if they don't, they'll go out of business. What does a world look like where machines do all the work, we become enfeebled?
Like some kids of billionaires are absolutely useless. Is that what we're...
Yes, in fact, we would all be kids of billionaires. And, one obvious consequence would be that we lose the incentive to learn, we lose the incentive to be independent, to achieve. In a sense, our civilization would end because it would no longer be a human civilization. To me, that's almost worse than extinction.
I mean, people have worried about this for a while, right? I mean, Turing even was concerned about this.
Oh, he was more than concerned. He was terrified. In fact, he said, it's hopeless. We should have to expect the machines to take control, is what he said.
How did he resolve it, though?
He didn't.
He just left a message for the future.
Yep. There's no solution. There's not even really an apology. It's just, this is going to happen.
Well, that's a little bit disconcerting, wouldn't you say? So is it inevitable is now the primary question, because if we understand the risks and we're mitigating the risk and putting guardrails in place at this point in time, then we have a lot better chance of controlling that outcome versus in our current paradigm where we have the biggest companies in the world building out as fast as they can advanced AI models with very little regulation, very little guardrails. And in fact, these same AI companies are also lobbying for even less regulation. And there's a clip where the Nobel Prize winner talks about this, and this is how we're going to close the video. We have a couple more clips to react to, but he says something along the lines of 1/3 of AI research should be on AI safety. And it's not even close to that. So let's keep watching and thinking about this.
Is that we have just one example of human-like intelligence, i.e. us. And AI now is definitely not a replica.
It is the neurons inside our own brains and how they signal to one another that inspired the artificial neural networks driving the AI boom.
If we're going to build a human-like general intelligence and beyond, could the key be a better understanding of our own mind?
One of the questions is, could you make a map of the brain so detailed that you could try to simulate it in a computer? Could you make a software simulation of it?
Neuroscientist Professor Ed Boyden is trying to understand the hardware of our intelligence by creating a digital map of the brain.
The brain is complex. Brain cells make all sorts of things, right? They make cannabinoids, molecules that act kind of like the active ingredient in marijuana, right? They make gaseous molecules like nitric oxide that diffuse in all directions. For a lot of these molecules, we really don't know what roles they play in most decisions, emotions, behaviors, and so forth.
So for everything that we know about the human brain, when it comes to understanding at the level of like individual synapses and structure, I mean, the way you're describing it is that we've barely scratched the surface.
We know very little about the circuitry of any brain, frankly. There's one worm, which has 302 neurons, where the wiring has been mapped out pretty well.
With around 100 billion neurons, the human brain might have to wait. Ed's team has started with some of the simplest of living things, including the C. elegans worm.
So that gives us a little bit of a barometer or a little bit of a measuring, something to measure against. Really, well, we don't even really truly understand how our own minds work, and we're building essentially a different intelligence, right? Whether you want to call it an AGI or an artificial intelligence, whatever you want to call it, we're building a different intelligence, something that is able to process input and provide output, just like you and I at our most simplest form is we process input and provide output. So let's hop over to the last video.
Chief scientist at OpenAI.
To just set up a large neural network, which is a large digital brain.
In 2023, he was part of the group that pushed out CEO Sam Altman, reportedly because they didn't trust that Altman was prioritizing safety.
I was quite proud of him for firing Sam Altman, even though it was very naive.
Naive, Hinton says, because OpenAI employees were about to get millions of dollars that would be jeopardized by Altman's departure. Altman returned, Sutskever left. Hinton criticizes his former colleagues at Google more reluctantly, but says they're falling short too.
Were you disappointed when Google went back on its promise not to support military uses of AI?
Very disappointed.
But it's part of a pattern, Hinton says, adding Meta and xAI to the list of companies racing faster than they should.
For example, the fraction of their computer time they spend on safety research should be a significant fraction, like a third. Right now, it's much, much less.
Hinton, now on the AI sidelines, says government regulation is needed, but doesn't expect it soon.
Okay, so let's kind of just react to that and then tie all these concepts together. So on this channel, we talk a lot about quantum computers and what quantum computers are going to be able to do. So one comparison is like this Apple Silicon computer with some of the best-in-class hardware that's available is a bicycle compared to a quantum computer. When a quantum computer matures, will be like a spaceship. Okay, so we're not even talking. This isn't an iPhone 6 to an iPhone 11. This is a totally different ball game when it comes to the hardware and what we're able to do through the hardware. So we have that whole piece of it, right? Which is we're excited about quantum computers on this channel. We talk about them all the time. We talk about investing in them because we're just excited. We're tech nerds. But at the same time, these AI models, like they're currently running on AI data centers, right? Which are supercomputers. They're running on NVIDIA chips. They're running on our phones and local models, and there's a limit, an upper limit to the power. But when we start putting these AI models, when we start giving these AI models a spaceship instead of a bicycle, what happens? And what AI pioneer Geoffrey Hinton is saying here, and by the way, he's won a Nobel Prize for his work in machine learning, is 1/3 of our research into AI should be safety and regulation. And we're not currently in an environment where that is the reality of what's happening. So we're kind of sprinting towards what outcome that's going to be. And there's obviously positive things that can happen, right? But we need to have a balanced view of all of it, right? So positive things, we can have rapid advances in medicine, technology, in science, in any metric that you can think of, financial systems, weather prediction, seismology, sensing, quantum sensing. There's so many positive things that can come out of the quantum computer advances and AI advances. But on the other side of this, how do we ensure that we're regulating, that we understand the dangers of, would an AI make a copy of itself and put it on a different machine and then work on its own? Would an AI see humans as potentially an obstacle or a barrier or something that needs to be eliminated or controlled? And you think about these things and you're like, oh, that's improbable, but it all comes down to context, right? So it's how an AI views itself. Does it view itself as a helper, something that helps humans, or is it possible that it could at one point someday be more concerned with its own self-preservation? And that's the interesting thing here is, what is self? What are we creating? And what are the consequences, both positive and negative? So I hope that this has been a thought-provoking episode. If you're new to the channel, please consider liking and subscribing if I've earned it. And I hope you have a great weekend. We'll talk to you all soon.